Hello students, welcome to a study doubt. This question is from physics chapter nuclei. In the question we have to calculate the height of potential barrier for a head-on collision of two deuterons. The height of potential barrier is given by the Coulomb repulsion between the two deuterons when they just touch each other. Assume that they can be taken as hard spheres of radius 2 Fermi meter. So according to this question, here we have two deuterons. So let's take, this is one deuteron and here is another deuteron. And here is our nucleus. This is the nucleus. And we know that nucleus carries positive charge. So this is a positive charge here. Here is also positive charge. Now, when both of the deuterons are ready to collide with each other, let's assume this is moving in this direction. So when it is moving in this direction, we will notice that these both of the nucleus will repel each other. These two nucleus will repel each other. So we have to find what is the maximum potential energy that will be stored when they are about to follow the head-on collision. So we can use the potential energy formula. U is equal to K Q1 Q2 by D. D is the distance between the two nucleus. So let's take, this is our D. So according to the question, radius is given as 2.0 Fermi meter. So total distance will be radius of one deuterium plus radius of another deuterium. So total is 2r. And its value will be 4 Fermi meter. So let's substitute the value. U is equal to K is 9 into 10 to the power 9. As the nucleus has only one positive charge, so the charge is 1.6 into 10 to the power minus 19 Coulomb whole square divided by distance is 2 into r. So U is equal to 9 into 10 to the power 9 into 1.6 into 1.6 into 10 to the power minus 38 divided by 4 into 10 to the power minus 15. Fermi is 10 to the power minus 15 meter. So U is equal to 23.04 into 10 to the power minus 29 divided by 4 into 10 to the power minus 15. So U is equal to 5.76 into 10 to the power minus 14 joule. So this is the maximum potential energy that will be developed when we have two nucleus are reaching near to each other. And during that time, whatever the kinetic energy of these two deuterium have, it will be equal to the potential energy. So that's what total kinetic energy will be converted to potential energy. And after that, they start repelling each other. We can also convert this potential energy unit joule to EV. So we know that 1 EV is equal to 1.6 into 10 to the power minus 19 joule. So 1 joule is equal to 1 divided by 1.6 into 10 to the power minus 19 EV. So here U is equal to 5.76 into 10 to the power minus 14 into 1 by 1.6 into 10 to the power minus 19 EV. So U is equal to 0.36 MeV. So both answers are correct, either in term of joule, this is correct answer, or in term of mega electron volt, this is the correct answer. So I hope you understood this question. If you have any doubt, you can mention it in the comment box. I will try to resolve it. Thank you so much.